Hi guys, so this one's just going to be a very quick video. You have a couple of built-in videos within the PowerPoint. We are not going to watch them together. You could pause this video and then watch them and then come back on. So let's go ahead and get started. Tuesday we talked about tectonic plates and how they work, and they're like little puzzle pieces. Yesterday we talked about how inside the globe we have internal forces. Like convergent, transform, and divergent that are going to kind of move those tectonic plates, and we are going to have landforms like mountains and valleys that are going to occur because of those internal forces. Today we are going to be focusing on external forces, so things that are happening outside of the surface of the earth, which we are really going to be focusing on erosion and weathering, made possible because of wind and water. Okay, so let's go ahead and get started. On this PowerPoint, slide 3, you are going to put in your own words. If you're using my words, that doesn't help you because your brain isn't doing anything. The reason why you want to copy and paste is because you want me to do the work, and it doesn't help you if I'm giving you the words. So it needs to be in your own words so that if your brain is thinking about it today, tomorrow when you take the test, your brain's gonna be like, oh yeah, we already talked about this, and know exactly what to do, and then you'll make hopefully a better grade, okay? You should probably stay on this slide. I'm gonna go back to the other slide, and I'm going to start working with that. So erosion is the movement of weathered materials like gravel, soil, and sand. Most agents of erosion are going to be water, wind, and glaciers. So this idea of if you have, well, let's talk about this picture first. If you have this windstorm that is coming and it's going to kind of start damaging some of the other layer, and it's going to pick up gravel, and then even that gravel is going to be like hitting on some of these other buildings that we see in this picture. Weathering is a gradual breakdown of rock at the Earth's surface into smaller and smaller pieces. This takes millions of years. So if you're looking at this photo, you see a river way down at the bottom. Millions of years ago, that river was way up here, okay? This was all flat land, and then the river just starts to kind of shave off part of the rock until eventually it looks like this. So it's like shaving as it's going. It's weathering, and it's taking off small, tiny particles of soil, of sand, of the rock particles, and that's just being taken further down the river until finally we have just this big canyon that is going to occur because of all of the weathering that is occurring. Gravity is the universal force of attraction. So you take something, it falls, and there you go. So vocabulary, just went over that, and make sure that you are doing your own hashtag. Again, guys, the reason why you hate doing this so much is because this is going to help you be a better student. Just kind of like thinking about it is going to really help you tomorrow, so that it doesn't, like, your brain doesn't panic when it has to think about this all on its own. Looking at this one, we have a video. I want you to watch the video. It's very important and kind of talks about some of the different erosions. One thing, though, that I just really wanted to kind of talk with you.
Even if you pick up a rock and throw it into the broken piece.
When you are looking at this one thing I just need you to understand is this was all covered in, okay? It was all covered in. Look at how thick that rock is at the top. This is all covered in, okay? It was all solid. There was no passage through until finally one time there was like a little hole, and then that hole got bigger because the wind is kind of shoving itself in it, and it's kind of taking off part of this side, okay? So that is just getting bigger and bigger and bigger, and then eventually we're going to get it so big that this little top portion up here is going to be weathered away, and we're not going to see it. So like in 3,000 years, there's very good possibility that normal people like who don't know about weathering are going to think, oh, these were two separate rocks. They're just different, and they look very similar. When in fact, it's all one rock with just a hole in the middle. Okay. Let's go ahead and continue. Here we have mechanical weathering and chemical. So in mechanical weathering, we're going to see the physical breakdown of a rock, pieces breaking off, but the physical state remains the same. So I have a sticky note, and I am going to rip it. Okay, it's ripped, but it's still a sticky note. Okay, it's still a sticky note. It's just ripped. On this side, we have a chemical weathering. So changes actual makeup of rock, changing the minerals that make up the rock or combining them with new chemical. So if we were talking about having a chemical reaction with the sticky note, the one that's broken, I could light it on fire and it will no longer look like a sticky note. It will no longer feel like paper. It would be ashes and it would be dirty and messy. Okay, so those are going to be kind of the difference of what's going on. Mechanical, it's still the same, and it's still going to be a rock before it changes and after it changes. But on the chemical side, there is some type of chemical reaction, like the chemical makeup of that item has changed. So mechanical. We have a rock here in our picture, and we are going to have water dripping it. It freezes overnight, gets really cold, so it can't be here in Texas. And whatever happens to liquids when you freeze them, they expand. So if you've ever put a Coke in the freezer and you just, you want it to be really, really cold, but then you forget about it. And then the next time you open up your freezer, like the whole thing just combusted. Well, if you really wanted to, like the frozen Coke, it's still Coke. I guess you could, warm it up and drink it. Ooh. The container inside the Coke, like it's still going to be there. It's just going to be broken. So it's still Coke. It's still the container. It's just expanded and it bursts. And the same thing is going to happen here with this rock. When the water comes into the little crease to like a crack in the rock, then the water comes, wiggles in, and then it busts it open. Okay. So it's rock, changes, still rock. Okay. On this side, though, this is a picture of a rock. I want to say it's limestone. I think there's some limestone built up into it. And there is water and moisture just coming off of it. And so it creates this kind of like crust on it. If you've ever gone to the caves near San Antonio, you're going to see things similar to this, where inside the cave, there's water and moisture building up on the ceiling. And so you start to see like these icicles, but they're not icicles. They're not made out of it's the rock having a chemical reaction with the water. And so now we kind of get this like crusty kind of material that starts to do it. As you're going through those caves, you're not allowed to touch the sides because the oils from your fingers would like destroy it. There's this like one portion where people were touching the walls off to the side and it was like orange and gross and nasty. And so it's just that idea of like chemicals between the water and the type of rock that you're dealing with. On this picture, you could see that this is water that is kind of dripping and coming down, and so it's causing coloration within the thing. So chemical, think of, we're in a chemistry lab and the substance that you are pouring is going to change. Like you're never going to take it apart. It's created a new item. Versus the mechanical, it's a rock when you start. You may have, broken it to bits and pieces, but it's still paper. It's still part of a sticky note. Okay. Versus if I were to light it up on fire, and then it would completely change how it feels, how it looks. maybe how it tastes, but don't ever taste anything like that. It's gross. All right, so major differences there. Let's go ahead and go to our next one. This question is asking, will chemical weathering occur faster in a humid climate or arid climate? I was really surprised. I had some students know what arid is. And when I asked them why did they know, they just said that they magically knew. Arid means dry. Okay, so they the question's asking you, will chemical weathering occur faster in humid climate or would it occur faster in dry climate? Arid is going to be a very important word. We're going to kind of see it constantly throughout the year. So arid means dry. I'm going to ask you, our weather here in Houston, are we a humid climate or are we a dry climate? Houston is very humid. You go outside, it could be 90 degrees, but holy moly, it feels like 99 because there's so much moisture in the air. You could spend an hour on your hair and it's all nice and pretty. You go outside and there is moisture in the air, and then your hair becomes frizzy and maybe not exactly how you had planned for it to look. So you should probably pause the video, you should answer the questions, and then let's move on. On this one, we are looking at acid rain. There was a student who really thought that acid rain was like a myth, like we talked about it in class, and they're like, wait, like it wasn't until like several minutes later that he's like, were you joking? And it's like, no, I mean, acid rain really does exist. So acid rain is like on a pH scale, okay? Remember science. Rain is going to, let's pretend, I'm not a science person. If you are, maybe you could ask someone and find out. Let's pretend that rain is over here. Well, when we add air pollution to it, now the rain is going to move a little bit on the closer to like the pure acids for it, okay? In some cases, it does hurt when the acid rain hits you, but for the most part, it would probably like irritate our eyeballs. And there have been cases that we see bigger damage of it, and then we've seen other cases where it's just slightly air pollution, so there's a slight elevation within the acid of that raindrop. And these are examples of acid rain occurring, and we can see how this rusted thing is now kind of like getting a little bit worse. On this side, it looks like, I don't know, this is hair, this is an ear, this is a mouth that's open. I think that would have been a nose, and then that's like an eye with an eyeball in it. And on this statue, like all of the features are really starting to like blend together. It's kind of hard to see the distinct features that it had before. And it's the acid that's kind of like melting it all together. The statue on the next slide shows it a little bit better. So here's a question. If acid rain is normal in a certain area, does the surrounding countries have a moral obligation to help solve this problem? So I am asking you, if Houston were to have acid rain regularly, would Mexico be obligated to help the U.S. to help Houston get rid of that air pollution? I don't know. I'm not going to be grading you so much on, you have to say yes, or you have to say no, or you have to be in the middle. I am going to kind of really be looking if you're able to support your argument. What we saw with the last test and what's going to happen again tomorrow is that you need to you need to say that this is what it is, and then you need to tell me why you think that. Okay, that why is going to be such an important factor. Make sure that you are fully thinking your ideas out. If you're saying that they are not obligated because environment health is important, well, that kind of like disputes each other. So just make sure that you are doing a good job on that. Chemical weathering, acid rain. This is the statue. Like on this side, you can see her lips. You can see like she has like a little indentation on her chin, her eyes. You can almost see like even her eyelids. That might be her eyebrow. Her neck, you can see how there's like a wrinkle, like a from stretching her neck that way. Her robe, her like jacket thingy, you can see all of the kind of folding within the robe. And then on this side, it just her robe has just kind of like melded into her body. She doesn't really even have a face anymore. I think this is a veil, and that actually looks pretty decent. But like her face just looks like something out of a monster movie. So this is Acid Rain kind of taking some of that off. On this one, we have 2 videos. This video, the lady who talks in it has a very soothing voice, but she does kind of explain it pretty well. On this one, this guy must have taken a Saturday and went to these botanical gardens and then like another statue within that area in the Washington, D.C. area. And it shows like the effects, like the evidence of this acid rain. So I thought that was pretty cool. So we looked it up, and apparently on the eastern coast, on the U.S. from D.C. going up towards Canada, that is the area most prone to get acid rain. And then China and parts in Taiwan were also other places that experienced acid rain. So there you go. I tried looking to see if Houston got any acid rain. I mean, it was the last time, but I wasn't able to find any answer on that one. Erosion, we already talked about this. It's that movement of weathered materials. And so like right here, I'm going to assume that this started off as a road. I don't think it's a river. Might be a river, I don't know. But we're going to see that like wind is going to kind of like break those walls. If you ever go to Austin and you're driving, there's like these limestone rocks. And as you are going, like the wind from the car is kind of crumbling the limestones of that particular river. Over here, again, we have our river. Guys, every river has the potential to be the Grand Canyon. Okay, there we go. Every river that you see has the potential of becoming the Grand Canyon if the water is, if the current is strong enough, and if the water source is there for millions and millions and millions of years. This is an aerial view, and you can kind of see little veins of water coming in, and then you can see that, kind of digs into the rock. On this side, we have a kind of valley that is starting to form because of the river. You are going to notice that there is more fertile soil because it's all of the sediments that is being pushed by the stream and gets deposited downstream. All right, here's our wind thing that we had talked about earlier. Guys, if you were to be like standing next to it, you're going to be standing on a lot of gravel, a lot of sand, and all of that small pieces of particles are part of the rock. That's like where the wind just kind of kept shaving it off, and now you would have sand around that area. All right, on this one, you have, you're going to define it in your own words. You're going to define it in your own words, and then you are going to give me an example in your own words. And then on the next one, you have 3 questions. What are the different types of weathering? You could just list them, give 2 landforms that show erosion, and explain what happened. You should have a water example, and you should have a winded example. And does erosion happen quickly? The answer is no, it takes forever. Hi guys, look at all of your 3 videos, look at all of your PowerPoints, and if you have any questions, log into Zoom. Remember, in Schoology at the top, your Zoom link is there. Log into Zoom at 10:30 tomorrow so that I can help you with anything. Bye guys.